In today's class, we are going to look at the quantification of protein using the Folin-Lowry method. We'll start our introduction by looking at what the Folin-Lowry method is. So the Folin-Lowry method, which is also known as the Lowry protein assay, is a widely used method for quantifying the amount of protein in a sample. So now let us look at some of the advantages and disadvantages of this method. So we'll start from the advantages. So one, the Folin-Lowry method is highly sensitive to protein quantification. And two, it's more accurate and reproducible. And three, the Folin-Lowry method can measure protein concentrations in a wide variety of samples, including biological fluids, tissues, and purified protein samples. So now let's look at some of the disadvantages. So one, the Folin-Lowry method is sensitive to reducing agent. So what it means is that if your test sample should contain any reducing agent, it will interfere with your result. And two, it is variably different in response to proteins due to their different compositions. And three, it's time consuming because it requires incubation period of say 30 minutes or more. So now let's look at the reagent used in Folin-Lowry method. So the reagent used in the Folin-Lowry assay for protein quantification include the Folin Staccato reagent and the alkaline solution. So the Folin Staccato reagent is basically a mixture of phosphotungstic acid and phosphomolybdic acid. And the alkaline solution is made up of alkaline sodium carbonate solution, which is used to create or provide alkaline conditions for the reaction to occur, and copper sulfate sodium potassium tartrate solution to make available the cupric ions and to chelate or stabilize them. So what you have to note is that the copper sulfate in this solution makes available the cupric ions, whilst the sodium potassium tartrate chelates or stabilize them. So other materials used in the Folin-Lowry assay include a protein standard such as bovine serum albumin for plotting a standard or a calibration curve, a test sample containing protein for analysis, distilled water for dilution, and a microplate reader or spectrophotometer for absorbance reading. So now let's look at the principle under the Folin-Lowry method. So what you have to note is that the Folin-Lowry method is based on a combination of two different reactions. So the first reaction is the biuret reaction, which involves the reduction of cupric ions to copper 1 ion by the amide or nitrogen group present in the peptide bonds of the protein under alkaline conditions. And also, in this reaction, the cupric ions formed a complex compound. So this is the complex compound being formed, so which is also known as a biuret chromophore with the amide or nitrogen of the peptide bonds during which they are reduced. So this is just a diagram explaining how the two reactions involved in the Folin-Lowry method. Okay, so this is the first reaction and the introduction of the Folin Staccato to the production of the final product is the second reaction. So for the first reaction, as explained earlier, so we are saying that this cupric ion over here, which is being produced from the copper sulfate, is being reduced by the peptide bonds of the protein in our test sample to protein cuprous complex as seen over here. So this is the first reaction. So the second reaction involves the addition and the reduction of the phosphomolybdentic acid or phospholipid phosphotanninic acid, which is the key component of the Folin reagent, by the tyrosine, tryptophan, histidine, and to a lesser extent cysteine residues of the copper protein complex to molybdenum tungsten blue or heteropolymolybdenum blue, which has a blue-violet color and absorbing light in the range of 650 to 750 nanometer. So this is our second reaction, which involves the reduction of the phosphomolybdentic acid of the Folin by the amino acid tyrosine, tryptophan, histidine, and cysteine to a heteropolymolybdenum blue having a blue to violet color as seen over here. And this product has a maximum absorption at 750 nanometer. So now let's look at the test protocols, and we'll start by looking at the materials needed for this method. So the first is a protein standard. So example, we can use 1 molar BSA. And what you also have to note is that the choice of standard depends on the expected protein type we are working on. The next is alkaline cupric sulfate solution, distilled water, and the Folin reagent. And the equipment needed are spectrophotometer, the cuvette, and the vortex mixer or shaker, and this is optional. So now, let's look at the test method. So the first thing that we have to do is the preparation of the standard curve. And to do this, we prepare a series of dilution from our BSA standard solution to create a standard curve. So example, let's say we want to prepare this concentration from our 1 molar BSA. So we'll have to use a serial dilution to prepare each of these concentration from our stock, which is the 1 molar BSA solution. And what we also have to note is that this range should encompass the expected concentration of your unknown samples. And also in doing this, we must ensure accurate dilution using appropriate volumetric flask. Now the next thing is to perform the Folin-Lowry method using your standard or your sample. So to do this, we add 1 ml of our test solution or sample to 5 ml of alkaline reagent and mix. So after that, we leave to stand for at least 10 minutes. And what you also have to note is that this is the first reaction where the cupric ions from the copper sulfate react with the amide of the peptide bonds of the protein to form copper 1 peptide bond complex. And this is the bi-rate reaction. So the next is to add 0.5 ml of the Folin reagent diluted 1:3 with rapid mixing, and then allow to sit at room temperature for 30 minutes. And this is the second reaction where the copper peptide bond complex reacts with the Folin to reduce the phospholipid acid and the phosphotanninic acid to heteropolymolybdenum blue, so which is the final product or the final reaction. So the next is spectrophotometry. So after the incubation period, we measure the absorbance of each tube at 750 nanometer. So using a spectrophotometer with a blank. And the blank is normally distilled water treated identically to the samples, and it's used to zero the spectrophotometer. So data analysis. So to analyze our data, we plot the absorbance value of the standard BSA on the y-axis against the corresponding protein concentrations to generate a standard or a calibration curve. So after that, we determine the equation of the line, and we use the equation of the line to calculate the protein concentration of our unknown samples based on their absorbance reading. And for a detailed info and note on how to plot a calibration or a standard curve, I would advise you watch my video on calibration curve for detailed info. So this is just a summary of the Folin-Lowry method in quantifying protein. So first of all, we said that the Folin-Lowry method is used to detect the amount of proteins, and it is more sensitive than the Biuret method. Also, with the principle, the Folin-Lowry method is a combination of two reactions: the Biuret reaction, which involves the reduction of cupric ions by the peptide bonds of the proteins to protein corpus complex, and the second reaction, which is the Folin-Cicator reaction, involves the reduction of phospholipid phosphotanninic acid, which is a key component of the Folin-Cicator, by the amino acid tyrosine, tryptophan, and cysteine to heteropolymolybdenum blue. And this has a maximum absorption at 750 nanometer. Thank you.